So in the yesterday's class, we have discussed about SBT, that is the build tool, simple build tool, and how we can use SBT to build a Spark application in batch mode as well as in interactive mode. Okay, na sir? We can build application by using SBT in batch mode, and we can also launch a Spark application by using SBT in interactive mode also. Though both the things we have seen, both the approaches how we can do by using SBT. Okay, so actually I told you that we are going to see how SBT works in IntelliJ, but I did not install IntelliJ. Maybe I will get ready by tomorrow's class. Okay, today I will start with Spark SQL. What we can do with Spark SQL? We shall go with Spark SQL. I will introduce you to Spark SQL today. Okay. So already as I told you that there are 5 components in the Spark as of today. They are nothing but Spark Core, Spark SQL, Spark Streaming, and Spark Machine Learning Library, and Spark Graphics. These are the 5 components that are present in the Spark framework as of today. The data objects, the data storage objects in Spark Core are called as RDD. So just give me 1 second, sir. I will be back. Okay. The data storage objects in Spark Core, we call them as RDD, and in Spark SQL, the data storage objects are called as DataFrame, and we have one more data storage object here that is called as dataset, DataFrame and dataset. And Spark Streaming, the data objects are called as DStreams, DStream, and Machine Learning Library, the data objects are called as vectors. And in graphics, the data objects are called as graph object. So there are different data storage objects that we call it different components. So till now we have discussed about RDD. Now I am going to introduce you to this Spark SQL. What is this Spark SQL? What does it do? What type of data it can accept? All the things that I am going to show you. Okay. Now Spark SQL. Spark SQL. Okay, the name itself is saying here that SQL is saying a structured query language. Okay, this Spark SQL uses the language called as SQL type of language only, but this language is inherited from the ANSI SQL 2003 standard. They have taken this Spark SQL language. Its origins from ANSI SQL 2003 standard. Okay, that's the Spark SQL. What type of data can be processed by using Spark SQL component? The environment of Spark SQL is structured data mainly and semi-structured data. Structured as well as semi-structured data can be processed. Structured and semi-structured data can be processed by Spark SQL effectively. I'm telling you that effectively. Even it can process unstructured data. I will show you both now. Okay. It can process unstructured data also, but not effectively. Okay, but not effectively. So Spark SQL can process structured and semi-structured data effectively, and unstructured data to some extent. They cannot I cannot say effectively. To some extent, it can process the unstructured data also. Okay, that's it. Just let me tell you now. So to create RDDs, we have been used this SC. Just let me go to next slide here. So to create one RDD, we used to write a statement like this: val r1 is equal to sc dot text file. What is this sc, sir? Ajay sir or Prakash sir? What is this SC here?
Spark context.
Spark context. Okay, to create RDD, we have been using this Spark context. Okay, till now. But to create these data frames and data sets in Spark SQL, the data objects are called as data frame and data set. So to create and to work in Spark SQL environment, we need to create a context called as SQL context. We need to create a context called as SQL context members of this. Okay, this I'm giving the list of all the context that are required. So in the Spark core, to work with RTDs, we require Spark context. We require Spark context. And to work with Spark SQL environment, we require SQL context. And to work with streaming environment, we need to create one streaming context. We need to create one streaming context. Remember these three. And the no specially contexts are required to work with machine learning and graphics, but these are required to work with these three environments. Spark context for Spark Core, SQL context for SQL, and the streaming context for Spark streaming application. Okay, and these are the contexts required, and this is the component, and this is the data object or data storage object. Okay, RDD, data frame, dataset, dstream, vectors, and graph objects. So I will show you now how to create the SQL context and how to use this SQL context to create a data frame and a data set. Okay, sir. In the industry, most of the people now the industry is going with Spark SQL only more. Why? Because this Spark SQL can process structured, semi-structured as well as unstructured data also. So the data is whatever the industry is now trying to process the data, most of the data will be structured or semi-structured only. Unstructured data is under rare situations like weblog data, IoT data, such kind of data only we are going to have in unstructured form. Remaining all the stuff like the data from RDBMS, like the data from NoSQL databases, from and like the data from some other shopping carts, they're going to maintain the data in semi-structured form. That is like in JSON form. The JSON data comes under semi-structured data. Likewise, most of the applications, most of the data in industry is still structured and semi-structured only. The unstructured data is there, but the applications are very different in that case. So the industry is no maximum they are using this Spark SQL environment only. But you may ask a doubt here. What is if we are data frame and data set are we are using for processing structured, semi-structured as well as unstructured data? What is the purpose of using these RDDs and Spark Core? These RDDs can process unstructured data effectively. Unstructured data effectively. Remember this. Effectively. To process unstructured data effectively, we can use RDD. I gave you this statement here. Even Spark SQL with the help of data frame and dataset, we can process unstructured data, but not effectively. Okay, but this unstructured data can be processed effectively by using RDD transform, RDD operations. Remember this point. So whenever we have pure unstructured data, if we want to process effectively, if we want to implement some complex coding, complex processing in that, go with RTDs, not with the data frames and data sets. Go with the Spark code. Is it clear, sir? Rajesh sir and Prakash sir?
Yeah, clear.
Yeah, Prakash sir, is it clear for you?
Clear,
Yeah, Prakash sir.
clear.
Yeah. Now I will try to show you the practically what is going to happen. Okay, let me show you practically in the cloud environment. So we start working with SBT only because already you are familiar with SBT, right? So today we shall create one more directory, mkdir Spark SQL. I create a project called as Spark SQL and enter into that Spark SQL. Okay. Now I make this directory as SBT project directory. Okay, now let us check for library dependencies. So what is the library we have? We have only Scala library in this. But what are we trying to work with now? We are trying to work with Spark SQL. Spark SQL, in the sense we need to add Spark SQL library as well as Spark core library also to this project. Then only we can work with Spark core and Spark SQL. Remember that even though we are working with Spark SQL, it is not just enough to add only Spark SQL library. We need to add Spark core library also. I will tell you why that. Okay, why it is required, I will tell you. But remember that to work with Spark SQL, we need to include Spark core library also into any project. I will tell you why. No, just let me add the libraries first. Then I will tell you why we need to do that. So to get the libraries dependencies information, where do we need to go with? We need to go with the Maven repository. Go to Maven repository and look for, first we shall look for Spark core underscore 2.10. Search for it. So this is the Spark core, and the version that we are using cloud environment is Spark version is 1.6.0. So click on that, and this is the library dependency. So just copy this and go to this and set and paste it. So this is the core dependency we are trying to include to the project. Spark core library dependency. Next we shall try to look, now we shall try to find out the Spark hyphen not core, now it is SQL. Spark hyphen SQL underscore 2.10. So it is showing the very first link is that one, Spark hyphen SQL underscore 2.10, 2.10. Click on it. And what is the Spark version? 1.6.0. Click on it. Okay, this is the library dependency for Spark core. Let us copy this and go to the project and again set and paste this. Okay, so after we make some changes to the project, save that session by using this command session space save, and again reload the project. Okay, now how to create a Spark interactive application? Just by typing here console, we can create a Spark interactive application by using SBT in SBT. So already we have used this dependency, what is called as this core dependency, already we have used in the yesterday's class. Okay, so yesterday we have used, so the libraries, the jar files required for core library, Spark core, already they are downloaded yesterday from the central repository, but we did not use this Spark SQL. Now the library will download, all the jar files will be downloaded now from the central repository for this Spark SQL. Let us see how it is going to work. Okay. Meanwhile, just let me give you some theory concept. So, to work with Spark SQL, I told you that to work with Spark SQL, we need to create a context called as SQL context. So, along with this SQL context, we have two more contexts here. One is called as Hive context, and one is called as Spark session. Spark session. These are the three different types of contexts that are available in Spark SQL. But remember, this Spark session will not be available in Spark 1 version, 1.x versions. This context is available only from Spark 2.x onwards. 2.x onwards. So in our environment in Cloudera, as we are using Spark 1.6.0, we don't find the Spark session. Okay, remember this. Don't get confused with this. The Spark session will not be available in this Spark 1.6.0. It is available from Spark 2.x onwards only. And initially, when they introduced the Spark SQL, they have created Spark SQL context, only SQL context. Later, they have introduced the Hive context after certain releases. After certain releases, they have introduced Hive context also. And after certain releases, what they have made is they have merged these two contexts. They have merged. Okay, they have merged the SQL context as Hive context, and simply again they are calling it as Hive SQL context only. That is what we can do with SQL context, and whatever we can do with Hive context. Now we can do only by using one simple context that is called as SQL context. Okay. Initially they introduced only SQL context. After some releases they have introduced one more context called as Hive context. And later they added the capabilities or the functionalities of Hive context also to SQL context. Now we have only SQL context. No, sir, we need not to create separate Hive context. If we create SQL context, automatically whatever the functionalities we have for Hive context automatically will be included to this SQL context. Remember that. And this Spark session is available only from Spark 2.x onwards. Okay, remember this point is very important. I will tell you what is Hive context, what we can do with the Hive context. That I will tell you later. Coming in the coming discussions, I will discuss about this. Let us see it started or not. Can you see, sir, here? It has downloaded some files. Can you see it downloaded repo1 maven org and Spark SQL. All these are jar files related to Spark SQL. Okay. Now, first, what is the first step to import the packages? org.apache.spark._. Okay, and this is the package to import to create to work with Spark core or to work with RDDs. Okay, to work, simply remember that this is the package required to work with Spark core, that is with RDDs. In order to work with Spark SQL, this is not enough. We need to import one more package. Import org.apache.spark.sql._. Import org.apache.spark.sql._. So this is the another package we need to import into our application to work with Spark SQL. Okay, now first, after this, valconf equal to new Spark context. First create Spark context. Conf. We know already these steps. What is this valconf and set master conf.set spark.master local. Let us go with local only, and conf.set spark.app.name. Let us say SQL app, SQL application. After this, now create Spark context. S equal to new Spark context of conf. So with this, what is going to happen? Spark context is going to be created with this. Okay, it is successful. Spark context is created here. Now, after Spark context is created, now we have to create SQL context. How we create SQL context? Just let us observe. Val SQLC equal to, I write SQLC equal to some SQL context, new SQL context of SC. Can you see here? What is this? What are we passing to this? Just observe very carefully here. To create Spark context, what is that we are passing, sir? Conf here. We are passing configuration object to create Spark context. But to create SQL context, what are we passing here? We are passing Spark context. So this is the dependency. In order to create, Michelle, in order to create SQL context, in order to create SQL context, compulsory we have to create Spark context. Creation of Spark context is mandatory to create SQL context. By supplying this Spark context only, we are going to create this SQL context. Without Spark context, SQL context cannot be created. So compulsory we have to create Spark context, then only we can create this SQL context. Remember this point. Is it clear, sir? Now, that is the reason I imported two packages. That is org.apache.spark as well as apache.spark.sql also. Just I am giving the steps once again. Just let me tell you. This is the first package we have imported. Okay, and this is the second package, spark.sql. First, we have created configuration object, and with this configuration object, we have set the master and we have set the application name. After that, we have created Spark context with the help of conf. Now we are creating SQL context with the help of the Spark context. Now SQLC is the SQL context. Remember that. SC is the Spark context and SQLC is the SQL context. Is it clear, sir? Now, okay. Now, so what we can do with SQL context is, with SQL context we can create data frames. Okay, the data storage objects in Spark SQL environment we call them as data frames and data sets. So by using SQLC we can create data frames and data sets. And by using SC, that is Spark context, what we can create RDDs. Remember these two. By using Spark context we can create RDDs, and by using SQL context we can create data frames and data sets. Is it clear, sir? Right. So if it is fine, then now I will try to show you how to create RDD and how to use this, how to create data frames, everything I will try to show you in this program. Okay. Is it clear, sir, up to this point? Rajesh sir and Prakash sir?
Yeah, clear.
Yeah, clear.
Yeah, fine. Then, so what did I tell you, sir? By using SQL context, we can effectively process structured data and semi-structured data. Structured and semi-structured data. So what do you mean structured data mainly? The structured data is nothing but the data in the form of tables, rows and columns. The data that we get from RDBMS mainly. RDBMS in the sense some MySQL or Oracle or Sybase or Derby, some of the RDBMS applications. And semi-structured data in the sense mainly these JSON files and XML files. Okay, these files will be used as the semi-structured data, and mainly tables will be used as the and are called as structured data. So now I will try to show you how to get the data from these two, how to get structured data as well as unstructured data by using this SQL context. Meanwhile, I will be working with Spark context also. Okay, just understand where, try to see here information. Okay, but for that we need to have some JSON data in our application. Let us try to download some JSON data from the internet. Why? Because I don't have JSON data with me now. Let us download some sample data. Um, Sample JSON file download. Download some JSON datasets in JSON Studio tutorials. Let us look for some JSON data here. JSON data of World Bank. So let us download this. So it is downloaded. The World Bank .zip. Let me go to Cloudera and downloads World Bank _zip. Let me extract here. So this is the JSON, the world underscore bank dot JSON. Okay. Just let me open this data first. Do you find, sir? This is the JSON data. What is the format of JSON data, sir? What is the format of JSON data? Ajay sir, do you know? And do you have any idea of JSON data? Let me create a new file. This is the format of JSON data, sir. The data will be like this. Okay, let me type some JSON data here. Name equal to Rajesh, let us say. Sorry. Name colon, not equal, comma, city equal to Hyderabad, comma, some equals, let us say some grade colon 1. Next again, name Karunakar and city equal to Hyderabad and grade equal to, let us say, sub 2, and name equal to Prakash and city, sorry, I is not equal to, I've been using this statement, is colon. Is colon, and here also it is colon, everywhere it is colon only. City, let us say from Chennai, and grade, let us say equal to some 2. Let me create one more record. Name some Priya and city colon, sub Delhi and grade some 3. Okay, so let me save this file. Save as some desktop, some sample.json. Sample.json. Okay.
No, just
Yeah.
remove equals.
Yeah.
Remove equals to just another.
Your voice is not clear, sir. Sorry. This is colon. Sorry, this is colon.
Yeah.
Yeah. This is colon. Is it clear now?
Clear.
Yeah, fine. So I saved this file, some sample JSON file. I just saved onto the desktop sample.json. Okay, let us do this now. Val df1 equal to sqlc. What is the context we have created? SQL context sqlc dot format. What is the format? JSON dot read. JSON dot read and load this file. Where do you have this file? We have this file in the desktop. Where is it? Sample.json here. Let me copy this and paste it here. So I think this doesn't work here. It works in Spark. Just let me check out once. SQLC dot JSON. Yes, JSON file it is. Submitted this. Val df1 data frame is equal to sqlc dot JSON file and paste this file path. Okay. it is creating a data frame. This is how, this is the statement. This is the statement to create a data frame. sqlc.json file. What is the file that you're trying to load? So I'm trying to load JSON file by using which context? SQL context. Why? Because why I'm using SQL context? SQL context only can be used to read semi-structured files and structured files. That's why I'm using the SQL context, and the type of file is JSON file, and this is the JSON file. Okay. So after submitting this, what is going to happen? It is going to create a data frame. This is the data frame that is created here, df1. Okay. Now, how do we? Let me see that. Now, I would like to create a RDD. How do we create RDD? RD1 equal to sc dot text file, sc dot text file of let me store some data from desktop. Some file is there, sample.scalar. I copy this file and paste it here. Okay, this is the RDD, and what is this? This is the data frame. See the difference, sir, between these two statements. The first one is RDD and second is data frame. What is the context? We are using Spark context. What is the context here? We are using SQL context. What is the type of file we are trying to read? Text file. What is the type of file we are trying to read here? JSON file. Okay, remember, it's very simple. It's very same. Context dot type of file we are trying to read. Here also context dot type of file we are trying to read. Okay, text file, give text file as input. It's a JSON file, give JSON file as input. That's it. Okay, now how do we print the data of this RDD, sir? How to print the data of RDD? Rajesh, sir, how to print the data of RDD? RD1 is RDD here. How to print the data of RDD? RD1 dot collect dot for each println. We can print like this. So this is the data. This is the data we have in that file. This is the program. Okay. Now df1 is the data frame. Now how to print this data now? Okay, we use this statement df1 dot show. See this. Can you observe this? Sorry. Do you observe this now here? City, grade, and name. What is the file that we have created? JSON file. This is the JSON file we have created. Name, city, grade. Name, city, grade. Name, city, grade. Name, city, and grade. So how it has organized the data? It has organized the data in the form of a table. Is it like a table or not? Yes. City, grade, and name. Okay. City, Hyderabad, and all the fields like this. So this is how Spark SQL will read a file and it will convert that file into a tabular form. This tabular representation of data in Spark SQL, it is called as a data frame. Okay, data frame is data storage object only, but the representation to the user, that will be in the form of a table that we call as a data frame. Okay, what is this df1? Df1 just now we have created. This is a data frame. And what are the columns in that? City is one column, grade is one column, another one is name is another column. Okay, it reads this statement. This statement reads some JSON file. It reads a file and it is converting that file into a table. It's nothing but the table representation we call in Spark SQL environment as data frame. This is very simple. Is it clear, sir, now? How we are reading JSON file and we are converting into a data frame. Rajesh, sir, is it clear now? df1 dot show. So it displays the data like the city, grade, and name. Okay. Now let me make some changes in this file again. Instead of grade 3, now again I will add one more record here. Name colon some Kumar, city colon let us say some Pune, and let me specify here grade equal to 1 comma I'm adding one more field to this record. In the fifth record, this is for Kumar, I'm adding one more field. Let us say some salary. Salary, let us say some 20,000. Next, I'm creating one more record. Here, name equal to Santosh and hyphen. I'm not entering this city here. I'm missing that. This record is missing city field. Let us see what is going to happen. Let us give the grade as some 2 and I'm going to include salary. Salary, let us say some 40,000. Close it and save this file and again reload it. Okay, execute this statement again. So it is created now. Now let us print this now. df1.show. What is showing here? City, grade, name as well as salary. But you will find here uh, these fields, the first 4 fields are having name, city and grade. They don't have salary. Okay, and this 5th field is having an extra field called as salary, and the 6th field is missing one field, that is called as city is missing. So let us see what is happening here. So wherever some data is missing, the data is represented as null here. Okay, that column will be created, but wherever the data is missing for a particular record, in that it is going to show the data as null. Okay, now sir, it is going to show the data as null. Okay, this is how a semi-structured file that is called a JSON file can be loaded into by using Spark SQL, and it can be represented to us in the form of a table. Okay, now we have downloaded one JSON file. We shall try to load that file. What is going to happen? Let us see. Alright, well, df2 equal to sqlc dot json file of, let me copy that file. Where is it? It is in downloads, I think. It is in downloads. Let me copy this to first desktop. Paste it, and copy from the desktop and give the path here. Okay, world bind data. Okay, now let us try to print this. What is going to, let's observe df2 dot show. It is printing many records, it is printing the entire data, but we are not able to read. Why? Because the number of fields are more. Meaning there are many fields. Okay, but how to know the number of fields? How the number of columns? There are many number of columns. How to know the number of columns? Okay, that's it. Well, for that, df1, it will the first data frame. Let me show you how to do this. Print the schema. So if you want to know the columns and the data types, this is the method. DataFrame dot print schema. Similarly, try to print the schema for second data frame. So these are the different fields in this file. That's why it is, we are not able to understand it even though it is printed on the console. So many fields are there in this. There are many fields. Okay. So whatever the size of, whatever the number of fields, just if you pass the statement, directly it is going to read the data and is going to represent us in the form of a table. Very, very easy. Okay. Is it clear, sir, up to this point? If any questions, just let me know. Hello?
Yeah, clear.
Yeah. Prakash, sir?
Yeah, clear.
Okay. Now, uh, mm, Now in this df2.show or the df1 dot print schema. From this I would like to select only grade and name. I want to select only grade and name. How do I do it? If it is some table, let us say, sir, if it is a table consisting of 4 columns, city, grade, name and salary, how do you select only grade and name? How to print it? Just can you tell me the command, sir, for it? SQL command, SQL query. If the name of the table is df1, how do we write a SQL query to print only grade and name? What do we print, sir?
Select.
Yes,
Select grade.
Yes, select grade, name from
the table.
the table name. That we write. Okay. See here, always going to happen. df1 dot select. Select. What do you want to select here? Grade, comma. What do you want to say here? Again, one more name. Dot show. That's it. This is somewhat different. It will be somewhat different to understand here. Can you see here? It is printing only grade and name here. Okay. Let me show you the command once again. This is the command. df1.select grade, comma, name dot show. This is how. It will be somewhat little different from the SQL. Okay, little different from SQL, but it will be easy. Once we understand, it will be very, very easy compared to even SQL. df1 DataFrame1 dot select. What do you want to select? Grade and name dot show. That's it. Very simple. Okay. Now let us say what I am to do is df1 dot. I'm printing the entire data. Okay. Now Rajesh sir, can you tell me some filtering requirement that you want from this data? What are the data that is getting, it is printing here. If I want to run some filtering operation, just give me some requirement, I will try to implement it.
Some salary greater than 2000.
Okay, salary greater than 20,000. Okay, let me set this. So how do we do is df1 dot select. Do you want to select the entire record or only the salary? Entire record in which the salary is 20,000, greater than 20,000, right? So if you want to select entire record, select here, select dot star, okay, where salary is not equal to greater than how much? 20,000. Okay, dot show. Did you get the result, sir? The entire record, city, grade, name and salary. Okay, so what is the command for this? This is the command df1 dot select star. Select star in the sense select entire records, all the records, where condition is salary greater than 20,000 dot show. Now this implementation will be a little different from actual SQL, but it will be easy. Once you understand it, it will be easy to implement. Okay. Any other requirements, sir, from Prakash sir, from your side?
Where city equals to Hyderabad.
Okay, where city equal to Hyderabad. df1 dot select the all the records. Select that all the records dot where city equal to Hyderabad dot show. What that is? City Hyderabad, grade 1 2, names are Rajesh and Karnakar, salary is null. We don't have salary field for that. For those two records, we don't have salary. That's why it is showing as null. Is it clear, sir? We can group also. We can perform grouping also here. We can perform grouping operation also. Can you tell me some grouping operations, sir? From this, what do you want to? Shall we try to group by city? Shall we try to group by city? We shall try to find out the number of records based on the group, based on the city. Okay, we shall try to group the records based on the city, and we shall try to find out the number of records. Let us see how we are going to implement this. df1 dot select all the records. Select all the records. Dot group by. Group by. What is the? We are trying to group by city. Dot aggregation. Aggregation. No. Count of star. Not small. Count of star. Dot show. I think it is not count. Something aggregate of. Is it count or something? This count only. Not some aggregation group by city and dot aggregation. Dot age stands for aggregation. And if you want to count the number of records, is it count or I think count has to work. I think just let me show you. Just let me check out what is the functions. Just don't worry, sir. Then I'm looking for some functions only. Count. Count. Count is the. Then what is the problem? I think this means there is some count of star. Dot something. I'm doing some mistake here. Some syntactical mistake. Aggregate of. Don't think we have this. Group by group the data and the dot. Just I will try to show, sir. I forgot the syntax of this one. Maybe I will try to show you maybe in the next class. I will try to check out how this works. Why actually I have been working in Spark 2. This is Spark 1.6.0. So there is some confusion for me also. Just I will make you this clear maybe in the tomorrow's class. Okay. Now, so this is how we create some data frames. Okay. And till now we have seen only what called as we have seen JSON file, how to read JSON file and how to perform some operations on it. I will try to show in the coming up class. I will try to show many different operations like joins, grouping operations and partitioning, bucketizing. All these operations I will try to show you. Okay, just remember this. Now, what are the different types of files we can read by using this SQL context? I told you structured data and semi-structured data. So what are those structured and semi-structured data and where we can read the data from? Okay, just let me just explain you. Okay, with this SQL context, just now we have seen JSON data. Okay, along with JSON, it can read CSV, it can read ORC files, it can read Parquet files, it can read what is another file format? Avro files. Okay, and XML files also. Okay, XML, JSON, and CSV, these fall under semi-structured. And ORC, Parquet, Avro, and table from RDBMS. Tables from RDBMS. Okay, all these come under structured data. Even though data is ORC, Parquet, Avro are tables, they know even Avro file, Parquet file, and ORC file, even they are stored in tabular format. Remember that. Even they are stored in the tabular format. That's why I'm calling all these as structured data. And this is semi-structured data. Okay, so it can read from, it can process XML files, JSON files, CSV files, as well as it can process ORC, Parquet, Avro tables from structured data. Okay, remember this. Now I will try to show you some file from this, RDBMS. How to read that? How SQLC can be used to read the data from RDBMS, something like MySQL. Okay, I will show you now. So in Cloudera, MySQL will be already installed. Okay, just we need to know how to use it. That's it. I will try to show you now that. Open to this, and let me open another tab in this. Now, MySQL -u root -b. The password will be Cloudera. This is a MySQL, and let us see what are the tables we have in this. Do we have any tables in this? Let us verify. Show tables. No database selected. Show databases. So there are different databases. Let us see if there is data in any database. Let us go with some NAV or CM. Let us see if there is a data in CM. Use CM and show tables. No, there are no tables in the CM. Just let us see another databases. Otherwise, we shall create one database and one table, and we shall try to load some data into it. No issues. Okay, right? Create a database db1. So one database created, and use db1. We have entered into the database and create a table here. Create table from tab1 and name. What is the name? What is the name type? Varchar. Let us say some 20, comma age. Let us say some int. Okay, we have created a table. We have created one database. In that we have created one table. Let us load some data into this table. Insert into, what is the table name? Tab1 values. What is the first varchar? Name will be some Spark, and let us say age is some 5 years. So we have inserted one row, and let us insert one more row. Map reduce. Let us say age some 10 years, and let us insert one more record. Hadoop, also 10 years. Let us insert one more. Kafka, some 15 years, like this. So totally we have inserted 1, 2, 4 records into it. Just let us say show, so not show. Select star from, what is the table name? Tab1. So this is the data. Now we shall try to read this data from MySQL into Spark SQL. Okay. We are trying to read the data by using Spark SQL. How do we read the data? Just observe it. Val df3 equal to SQLC. We have created SQL context dot JDBC. The format is JDBC. Remember that. JDBC dot just JDBC of just let me see, just once verify. JDBC, yes, here we have JDBC. JDBC option, do we have option here? We don't have option. Yes, set option is there. We have this one. JSON for JDBC is there. Okay, let me show you. Just JSON of JDBC of dot JDBC. I think option is there. Just let me show you this. Let us try this. JDBC of URL. First we need to specify the URL. JDBC colon MySQL dot JDBC colon MySQL colon / localhost colon 3306 / 3306. That's it. /06 comma database name db1.db1 tab1 dot no. Let us just work this. We see just I forgot the syntax actually. This is different from Spark 2 and Spark 1.6. Just let me refresh all the topics today, and I will show you how to implement all these tomorrow. Okay, because for the syntax is different, slightly different. Okay, and just for today, remember that we can read, we can process structured data and semi-structured data. In this class, I could show only the what you call as JSON file. In the tomorrow's class, I will show you all how to read and how to process all the types of files. Okay, before that, I will introduce you something. Okay, that is called as. Let me tell you. Let me explain some theory concept. Tomorrow I will explain you. I will show you the practicals of all these types of files. I will get the data ready. I will explain all these types of files. Okay. Next. Here I told you one thing here. Spark SQL has totally, it can have three contexts: SQL context, SQL context, Hive context, and Spark session. So this Spark session is out of our discussion. Why? Because it doesn't support in Spark 1.6 now. But Spark SQL now it's supporting SQL context and Hive context. Now I will tell you what is the purpose of this SQL context and what is the purpose of this Hive context. So Hive context is, the purpose of Hive context is, the purpose of Hive context is to read the data from Hive. If Spark SQL, if we want to read the data from Hive into Spark SQL, okay, then we need to have the context called as Hive context. If we want to read the Hive data from Spark SQL, then we have to create this Hive context. Remember that. If we simply use SQL context, it may not support to read the data from Hive, but in order to read the data from Hive into Spark SQL, we need to create Hive context. Just I will try to show you how to create this Hive context and how we can read the data from Hive, how we can integrate this Hive and Spark SQL. We need to make integration. Remember this. Spark SQL and Hive, these two are there. If we want to access the data of Hive in Spark SQL, first we need to integrate these two. And after that we need to create Hive context. Then with the help of this Hive context, we can access Hive data into Spark SQL. The very first thing is, first we need to integrate Spark SQL with, you cannot say just simply Spark SQL, simply we say Spark with Hive. Then we need to create Hive context. Create Hive context. Okay, create Hive context, so that we can access the data of Hive in Spark environment. Okay, how do we do it? Okay, this later initially they have introduced Spark, people have introduced SQL context. Later, why they have introduced Hive context is, this is the purpose, to have the integration with Hive and to read the data of Hive into Spark environment. Further, they have introduced this Hive context. I will try to show you how to make this integration possible and how to create this Hive context. Let me show you now. Okay, so how did we create Spark SQL context? Just to see, I will trying to show you how we have created SQL context. This SQL context we have created val SQLC equal to new SQL context of SC. And what is the package we have imported? These are the two packages, org.apache.spark, and another package is org.apache.spark.sql _. These are two packages we have imported to create Spark context and SQL context. For the creation of Hive context, we need to go with one more package called as sql.hive._. Sorry, it is not working, I think. Directly we can get Hive context also directly, I think. Let me show you now. Val Hive C equal to new Hive context. SC. Hive context is also there, right? But it is not showing. sql.hive._. What is not working here? Sorry. The thing is, can you see here? What are the two libraries we have added here into this project? Just can you remember, sir? We have added two libraries, Spark Core Library and Spark SQL Library. And we have to add, to make use of this, to create this Hive context, we have to add one more library to this SBT project, that is Spark SQL Hive Library. Okay, just let me tell you now. Let me show you that in the Maven repository. Go to this Maven repository and sorry, here we have this Maven repository already. Now look for here Spark -SQL Hive. Let us search for Hive. It's, Hive _2.10 on SQL. So can you see something saying here? Spark -Hive. Okay, can you say Spark -Hive? We need to import, we need to add even this library to this project. Then only we can create Hive context. Okay, just let us try to create it. 1.6.0 Spark version. And how do we do it? And for this we need to come out of this. To come out this, we need to start this Spark context. So when we start this Spark context, automatically the SQL context is also going to stop. Sorry, not underscore, there is no underscore, sorry. Right. So we have stopped the Spark context. After starting the Spark context, to come out of this, type quit or colon, simply Q, or we can type quit also. Okay, now we are into again SBT shell. Now set, include this library, this in dependency also, copy it and paste it here. Okay, So we're also adding Hive library also to this. So now again hit console. Now we'll try to download that library. It doesn't take much time. It's a matter of some seconds only. Is it clear, sir, up to now what we have discussed? Rajesh, sir?
Yeah.
Yeah, yeah. The thing is, I used to work on Spark 2, so there are some syntactical differences between Spark 2 and Spark 1. That's why I'm not able to, get the syntax correctly now here. I will work today and I will show you tomorrow how to read all such type of files. Even I will download some sample files, CSV, Parquet, all those files. I will try to show you tomorrow in the class. I will try to show you all the entire practicals of this SQL, Spark SQL. How to read a CSV files, how to read what is it called as Parquet files, ORC files, Avro files, as well as how to read the data from RDBMS like Oracle, like MySQL. I will try to show you all this stuff tomorrow. Okay. Just meanwhile, let us try to start Hive along with MySQL. Just I am coming out of this MySQL first now. Exit, and I use Hive. Let us start Hive. Let us see here. Show tables. Let us check are there any tables in Hive. There are two tables in Hive. What is called as sample, another one is called sample 2. Let us see what are the data we have in sample and sample 2. No data is in sample 2. Still there is no data at all. Okay, let us see now. Let us try to first work with this. And I told you here, just observe. I gave you this statement that first, in order to work with Hive context, or what is the purpose of the Hive context is to integrate Spark with Hive. How do we make this integration? If we make this integration, remember that this integration we are going to make like this, the processor like this. So in Hive installation folder, there will be a file called as hive-site.xml. There will be a file called as hive-site.xml where in Hive installation folder. So we have to copy this hive-site.xml and put it in the Spark installation folder. Okay, we have to copy this hive-site.xml from Hive installation folder and copy in Spark under it some configuration folder. In Hive also, under some folder called as configuration, we'll have this file hive-site.xml. Copy this file and move to Spark conf hive-site.xml. So that will make us to access the data of Hive into Spark. That is what the integration of Spark with Hive. Remember this. How do we integrate Spark with Hive is just take this file hive-site.xml from Hive and conf folder and copy it into Spark under Spark and in it under configuration folder. Paste this. Then we can access the Hive data in Spark. This is what the integration of Hive and Spark SQL is. Now we are trying to create a Hive context. Now let's see. First we shall try to do this. How do we do this is, let me go to this. So where all this, just let me come out of this Hive also first. So where all these components are installed in Cloudera, In which location Hadoop, Spark, Hive, everything, all these components are installed. They are installed in this location, remember. They are installed in user library, remember that. Okay, just to see the list of files here, you can see here. In user library, we have all these files: Hadoop, Map, Reduce, Impala, Hive, HBase, Pig, Py, everything, all the files are there. So now we're interested in first Hive. Let us go to Hive and see what are the folders we have here. In that we have one more folder called as conf. Let us go to it. Conf is there. And let us see what are the files and directories we have in conf folder. Yes. Do we have a file called as -site.xml? Yes. This is the file that we are interested in now. Now we have to move this file. Where we have to move this file to? We have to move the file to Spark folder in that configuration file. In the configuration folder, we have to move this file to. That is copy. Where to copy is copy. What we need to copy here? Site.xml to where user lib/spark/conf. You have to move this. Permission. This one the permission denied. Perform this operation as sudo. Okay, now it is copied. If you want, we can verify. Just let us come out of this. Come out of Hive. Now we are in lib. Just go to Spark and in that go to conf and look for the libraries. Look for the files. Yes, we have now hive-site.xml in Spark configuration folder. Yes, that's it now. This allows us now. This allows us to access the Hive data from Spark now. Okay, this is ready with us now. So it is downloading here. The SBT is downloading all the jar files of Hive Spark with Hive integration jar files. Yes, it is over. It is starting now. Okay. Now, the very first thing is we need to import this package. Okay, core package. After this, spark.sql.hive. Let us use it now. It is available now. Previously, it has shown it was shown as an error, but now it is working now. Okay, no issues at all. Now, first we need to create Spark context. Whether you create SQL context or Hive context or whatever it may be, the very first thing is we need to create Spark context, without which only we can create any other context. Remember that. So for that, first create configuration object, new Spark conf. Okay, and set the master conf.set spark.master is local. I'm creating all this once again, but because already we came out of this session, right? Conf.set spark.app.name. This is some SQL array Hive context. Just I'm giving some random into this. And now create Spark context value is equal to new Spark context of conf. Now we have created Spark context. So now once the Spark context is created, if you want to create Hive context, we can go like this. Well, Hive context is equal to new Hive context of SC. So what is getting created? It is giving some error here. It is throwing some error. The root scratch directory temp Hive and everything should be writable. Current permissions are RWX. So we have some restrictions here. Restrictions we have write permission in HDFS. And temp hive /temp/hive, the permissions are RWX. Okay, now we have to make them as read. We have to make it in as write permissions also. Just let us verify where the temporary /tmp/i1 HDFS. Let us see. Just let us verify here. Let's go to just HDFS. And let's go back and /tmp. Where is tmp? /tmp. So this is tmp. In the tmp on Hive, what are the permissions we have here? We have only RWX. We have to make these permissions as I think we have to make them as 777. Let me do this stuff. That is HDFS DFS -ch to change the mode of permissions. We have to use -ch mode. Make it as 777 slash use not the tmp/hive. Permission denied. User is not the inode Hive. So what we have to do is just try to do this sudo. This sudo doesn't work here. Permission denied. User equal to root. Okay, now su root is Cloudera. No, it doesn't. This HDFS DFS -ch mod 777 /tmp/hive. Permission date change permission temp permission user equal to root is not the owner of inode equal to Hive. Who is the user? Just let us verify. Parent directory temp Hive content of directory /tmp. I don't know the user of this one. Just let us verify. How do we know it? HDFS ch mod is there. Just I will show that tomorrow. Maybe it is giving some problem here. Some write permissions and read permissions is showing some restrictions. Permissions are getting made. In the tomorrow's class, I will make it everything clear to you. Okay. How to create this? Already we have created Hive context here successfully. But only thing is, it is showing some error. We don't have the right permissions on this particular folder. I will try to rectify how to do this and how to resolve this issue. I will show it tomorrow. Okay. Just remember that only these points. Just try to remember in this class. What are these? Just I will try to recap the things. Okay. These are the different components, various components, and these are the data objects, and these are the contexts that are required. Okay. So currently we are dealing with Spark SQL. The data holding objects are called as data frames and data sets, and the contexts are SQL context and one more context, Hive context and Spark session. And Spark SQL, what are the different varieties of data that we can process by using Spark SQL is, we can process structured and semi-structured effectively, but we can process unstructured but not effectively. Okay. But what component can be used to process unstructured data effectively is Spark core programming can be used to process unstructured data effectively. Okay. Next slide. Here I'm showing you. So Spark SQL, totally we can create 3 types of context here: SQL context, Hive context, and Spark session. But the Spark session is available from only from Spark 2.x onwards versions only. But in a Spark SQL in 1.x versions, we can have SQL context and Hive context. What is the purpose of this Hive context is, this Hive context is mainly intended to access the Hive data into Spark environment. Okay, and what type of files? These are the different semi-structured files, XML, JSON, CSV, and these are the different structured files that we can process by using Spark SQL. Okay, that's it. And finally, how to integrate this Spark and Hive? That integration is nothing but moving this file hive-sci.xml from Hive configuration folder to Spark configuration folder. Later, we have to create Hive context. Then we can access the Hive data in Spark. So while creating Hive context is showing some permission restrictions. We'll try to show you all these practicals tomorrow's class. Okay, now sir, is it clear to you now up to this point?
Yeah.
Okay. So if it is clear, let us wind up the session for today, and we shall continue tomorrow, sir. Okay.
Okay.
Okay. Thank you, Prakash sir, and thank you, Rajesh sir.